Yesterday, or a couple days ago, we talked about completing the square to write our equation in vertex form. So we're still going to work on completing the square, but what you may have noticed in our first set of notes is that it was always just 1x squared, okay? And there was a reason for that. This b over 2 squared to get our c value to complete the square, it only works if a is 1. So we have to know, well, how could we complete the square if we have a quadratic where our a value, our leading coefficient is not 1, okay? So here I have 4x squared plus 16x minus 9. So the first thing that we need to do is divide out the leading coefficient. Okay, whatever it is, however messy the dividing out is, we need to divide out that coefficient from all of our terms. So if I take a 4 out of this quadratic, I'm going to be left with x squared plus 4x. And then I'm going to have negative 9/4. Okay, so I need to take a 4 from each term. So even again, if it's messy like this, that's what we need to do. Okay, then now we're set up to complete the square inside the parentheses that we're left with. So now inside here, we have a quadratic that has a coefficient of 1, leading coefficient of 1. So I'm going to still have this 4 out front, but inside my parentheses, I'll do what we were doing the other day, and I'll add in the correct value that would complete the square, and I'll subtract that same value at the end. Okay, so now I'm inside my parentheses. I'm going to complete the square. Okay, so to do that, we're going to do b over 2 squared here. So completing the square would give me 2 squared or 4. I'm going to add 4, and I'm going to take away 4 at the end. Now I'm still have this 4 out front, and inside my parentheses, I'm going to factor that perfect square trinomial. Okay, x squared plus 4x plus 4 is going to factor into x plus 2 squared. And then at the end here, where I have negative 9/4 and negative 4, I'm going to rewrite negative 4 as negative 16/4. And if I have negative 9/4 and negative 16/4, then all together, I'm going to have negative 25/4. Okay. So now here comes the trickiest piece, is to get it back into vertex form. We are going to distribute the leading coefficient back through the parentheses, which means, so here's my step 3. I'm going to take this 4 and I'm going to distribute it. It'll get multiplied by the x plus 2 squared, and it'll get multiplied by this term out back. So this is really why it's important, is I have to multiply that 4 back through this term here in order for it to give me my vertex. So I have 4 times x minus 2 squared and 4 times negative 25/4. Okay, so I multiply it. It's going to go in front of my parenthesis, and I'm going to multiply it by whatever term I have out back here. Now, what's nice is now I'm going to get rid of my fraction, because 4 divided by 4 is just going to give me 1, or 4 times negative 25/4 just leaves me with negative 25. Okay, now I have my quadratic in vertex form, and I could tell you my vertex is at negative 2, negative 25. Okay, and I'd be able to move from there. Okay, but we have to first take out that coefficient, do all the work inside the parenthesis, and then pull that coefficient back through. Okay, so let's look at a few more examples of quadratics that have coefficients. Now I'm just going to cancel that one right out. I do not like how that one worked out. So we're going to skip to the second example here. So I have a coefficient of 4, leading coefficient of 4. First thing I'm going to do is divide that 4 out. This will leave me with x squared plus 2x, and I'm going to give a little space here, plus 5/4. And a little space at the end. That way I can just go ahead and complete the square with without having to rewrite the problem again. Okay, so I divided 4x squared by 4, 8x by 4, and 5 by 4. Okay, that leaves me with this. To complete the square, I'm doing b over 2 squared, which gives me 1. So I will add 1 and subtract 1 from the problem. The first 3 terms should create a perfect square trinomial. Let's solve this 4 out front, and this will factor into x plus 1 squared. At the end, I have 5/4 minus 1, or minus 4/4. 5/4 take away 4/4 is going to give me 1/4 at the end of that parenthesis. Okay. Now, the last step is to distribute that 4 back through, which gives me 4 times x plus 1 squared, and 4 times a 4, giving me 1. Okay, and here's the vertex form of my quadratic with a vertex at -1, 1. Okay, let's look at one that's a little bit trickier in terms of how we end up having to complete the square. So again, I can never complete the square if I have a leading coefficient other than 1. So if I encounter a problem like this, first step is get that coefficient out of there. So I take the 2 out, leaves me with p squared minus p plus 3/2. So I've divided the 2 out. I'm moving space here, plus 3/2. There's parentheses. And I know that I'm going to add and subtract the same value to complete the square. So now on this one, when I go to find b/2, that's -1/2 squared. So I'm going to add in a 4th to complete the square. I'm going to add in 1/4 here and take away 1/4 there. And I know that if I'm following my formula, following my pattern correctly, that this is a perfect square trinomial. It's a little trickier to factor it though. I know it'll be p minus, because I have positive and then a negative. Okay, and then I know that this value is the b/2, is what I had previously had in here that I squared. So this is going to factor into x minus 1/2, or sorry, p minus 1/2 times p minus 1/2, or p minus 1/2 squared. Then at the end, I have to clean this up. So I'm going to rewrite this as 6/4 minus 1/4, which is going to give me 5/4 for that value at the end of my parenthesis. And then again, that last step, get that 2 back in there. So that's going to give me 2 times p minus 1/2 squared. And then 2 times 5/4 is going to give me 10/4, or reduced to 5/2. Okay. Another way to think about it is 2/4 reduces to 1/2. And then I have the 5 in the numerator. Okay, but 2 times 5 gives me 10/4 reduces to 5/2 when I multiply that, or distribute that 2 back through to my terms. Here's my quadratic in vertex form, and I know that my vertex is at 1/2 and 5/2. Okay, so we're still going to have to deal with fractions even when we're doing this work. Let's look at one more, and then you'll have some practice problems in your work today. So I take out my leading coefficient of 3. Now 3 is not going to divide evenly at all here. So I take out a 3, and it leaves me with x squared plus 7/3 x minus 4/3. Okay, dividing out that 3, and I know I'm going to add and subtract a value in there to create that perfect square trinomial. To get this value, I do b/2 squared. So that's tricky. 7/3 divided by 2. Now 7/3 divided by 2 is the same thing as saying 1/2 of 7/3. Okay, so I can think of it like this. squared, or that I will have 7, 6 squared. Okay, that's the value that I'm going to add in. 7, 6 squared is 4936. So really tricky to get the C value that would complete the square here. When I have a fraction divided, again, that's like, and remember, keep, change, flip, properties of fractions. Instead of dividing, we keep the numerator, change it to multiplication, and take the reciprocal of 2, which is 1/2. Okay, 7/3 divided by 2 is 7/3 times 1/2, which becomes 7, 6 squared gives me 4936. So I'm going to add 4936, and I'm going to subtract 4936. And now again, trickier is, well, okay, now I have to factor that perfect square trinomial that I've created. And I'll know it, I know it's x plus because I have plus here, but what's the second value? And remember that hint, hint, it's always whatever b divided by 2 is, which was that 7, 6. Another way to find this value is take the square root of that last term. Okay, so another way, if it's a fraction, take the square root of 1/4. Take the square root of 4936. Okay, that's going to be the value. That's the second term in your factored parenthesis. And then we have this mess here. So let's see. 4/3 and negative 30 or negative 4936. So 4/3, if I make this out of 36, is going to be 48. 36 minus 4936, is that right? Because I'm multiplying by 12. So then all together, I'm going to have negative 97. 36. Okay, combining the negative 4/3, which became 4836, and negative 4936. Now we have to get that 3 distributed back through. So that's going to give me a 3 in front of my parenthesis. And then for here, where I have, let me just over to the side, I have negative 9736 times 3. So I'm going to go ahead and reduce that. Okay, and 336 into 1/12. So I know I have negative 97 twelfths for the end term there. Really messy. Remember, the first example is messy like this too, but I didn't want to at least do 2 that are that messy. So there we have our vertex form, and our vertex of our parabola would be negative 7, 6 and negative 97 twelfths.